In our course, air resistance depends on two factors. Number one, the area of an object. An object with a greater surface area will experience a higher air resistance. Let's take an example of a parachutist. Very often we see parachutists in two specific positions. One where they have their hands and the legs spread out, the other where they have their hands and their feet tucked in. When their hands are spread out, they have a higher surface area, hence, they have a greater air resistance, and they have a slower terminal velocity due to a larger air resistance. What's terminal velocity? We'll talk about that in a while. But remember, in higher air resistance situations, your terminal velocity will be smaller. But when the parachutists have their hands tucked in, they have a lower surface area, hence a lower air resistance, and they will have a higher terminal velocity. Air resistance also depends on the speed of an object. The greater the speed of an object, the larger the air resistance experienced. This is an example that we talked about earlier in one of the videos. Try putting your hand out of a slow moving car and a fast moving car. In a slow moving car, the backward force, the air resistance you experience on your hand is going to be much smaller, while in a faster car, the backward force that you experience or the air resistance is going to be much larger. Terminal velocity is a very important concept which is a part of many questions. As an object starts falling to the ground, it experiences air resistance, which is initially zero. As we know that air resistance depends on speed, and if the speed is zero, the object will not experience any air resistance. The object is now falling and it will experience an acceleration of exactly 10 meters per second squared, as demonstrated by these diagrams. Your object falls with an acceleration of 10 meters per second squared means that its speed is continuously going to increase, and if the speed increases, your air resistance also increases. In the beginning, the amount of air resistance is very small, and then as the speed increases, your air resistance also increases to a point where now in this diagram 4 right here, your air resistance and your weight are equal to each other. Now when the total upward force, the air resistance, is equal to the total downward force, the weight of an object, it reaches a constant speed that's known as the terminal velocity. So we can conclude that as an object falls, its speed increases and its air resistance will increase to a point where it becomes equal to the weight. When the air resistance and the weight are equal, the object experiences a resultant force of 0 newtons. That's when the terminal velocity is achieved. When an object in free fall reaches terminal velocity, it will not accelerate anymore and the velocity becomes constant. So again, a very important thing to remember because it's a part of a lot of questions in kinematics. That is it for this video, kids. Inshallah, I'll see you in the next one. Bars out.